Hi, welcome to Module 2. In this module, we will start the course material by discussing some vocabulary related to data, how we collect data, and how we can summarize data. Chapter 1 focuses on vocabulary and data collection. In this chapter, you will be introduced to the vocabulary terms cases and variables. When we collect data, we obtain information about cases, and a variable is any characteristic that we are going to record for each case. For example, if we go into a 5th grade classroom and record the height and gender of each child, the cases are the children, and the variables, the pieces of information that we record from each child, variables are height and gender. Notice that gender is the variable. Males and females are not the variables. Those are categories within the single variable gender. Variables are classified either as categorical or quantitative variables. A categorical variable divides the cases into groups. For example, gender, in our last example, would be a categorical variable. It would divide our children into males and females. A quantitative variable measures a numerical quantity for each case. For instance, height be measured on a quantitative scale. We're going to see that these classifications are going to be really important throughout the course because the types of variables that we'll be working with will determine which of the methods of analysis are going to be appropriate for them. So we're going to revisit this idea of distinguishing between categorical and quantitative variables throughout the course. Often we will be interested in studying a relationship between two variables. If we're using one variable to help us understand or predict the values of another variable, we call the former, the one we're using to make a prediction, the explanatory variable, and we call the latter, the one we're trying to predict, the response variable. Some examples, if we want to know, does meditation help reduce stress? And meditation would be our explanatory variable, and stress level would be the response variable. If we want to know, does sugar consumption increase hyperactivity? We would be looking at sugar consumption as our explanatory variable, thinking that it may be influencing hyperactivity, which would be our response variable. Now, in section 1.2, we're going to learn about sampling. In general, anytime we collect data, there is some population, a large group, that we'd like to know about. But often it's too difficult to collect data from the entire population. Maybe it's too expensive, maybe the population is too big or hard to reach. So in these cases, we are going to collect data from only a sample or a subset of the data, and then use that sample data to make inferences about the entire population. Now, if we want to do this, it's obviously going to be really important to choose a sample that is representative of the larger population. So the goal of sampling is to select a sample that's similar to the population, only smaller. Sampling bias occurs when the method of selecting a sample causes the sample to differ from the population in some relevant way. So that would be a situation where our sample was not representative of the population in some important way. If sampling bias exists, then we cannot trust generalizations from the sample to the population. And what we're going to see in section 1.2 is that the best way to avoid bias is to take a random sample from the population. And if we do that, we will be able to generalize the results to the population that we sampled from. Now, section 1.3 focuses on relationships between variables. And we're going to start by distinguishing between association and causation. Two variables are associated if their values tend to be related. For example, at times when ice cream consumption is higher, there also tend to be more drowning deaths. two variables are causally associated, or we have causation, we sometimes say, if changing the value of one variable directly influences the value of the other. For example, if a student studies for an exam, his or her grade will be higher than it would have been if that student did not study. That's cause and effect, causation. In particular, we're going to learn to distinguish between experiments and observational studies. An observational study is one where we collect data by simply observing, and the researcher has no control over any of the variables that they're collecting. An experiment is a study in which the researcher actively controls one or more of the explanatory variables. And in particular, we're going to learn in section 1.3 how the choice of study design determines whether the study can be used to establish causation or not. That's going to be a really important takeaway point from chapter 1, so make sure you really focus on that idea. Chapter 2 is going to focus on describing data using descriptive statistics. In order to make sense of the data we collect, we need ways to summarize it and visualize it. Descriptive statistics is also sometimes called exploratory data analysis. We're taking the data and sort of taking a look to see what kind of information it might provide us. It's important to remember that the type of summary statistics and visualization methods like graphs and tables that are appropriate are going to depend on the type of variable or variables that are being analyzed. That is, whether they're categorical or quantitative variables. When we're working with just one categorical variable, we tend to focus our summary statistics on proportions. The proportion in a category is just found by taking the number of cases that fall into that category and dividing by the total sample size. Notation is going to be very important, and it's going to be consistent throughout this course. So whenever we are working with a proportion, if we're calculating the proportion based on sample data, anytime we do a calculation based on sample data, the number that we calculate is called a statistic. And in this case, for a proportion, a sample proportion, we are always going to use the notation p hat. P hat means this is a proportion calculated from a sample. Anytime we have data from an entire population, every single member of the population has had that variable collected, and we're doing a calculation based on population data. Numbers calculated from population data are called parameters, and the notation for the population proportion is P. So anytime you see this P, it means population proportion. Anytime you see P hat throughout the course, it means sample proportion. When we work with quantitative variables, we're generally going to want to describe three aspects of the distribution of that variable. First of all, we're going to want to know about the shape. The shape of distributions can be classified as either symmetrical, when we have something that's basically a mirror image on each side of the center. We can have a situation where we call it skewed to the right. This is when we have a tail of the distribution going off to the right. And we can have a distribution that we describe as skewed left when the tail is going to the left. So as you read through section 2.2, think about why we call the distribution skewed right and skewed left. Why is the skew in the direction of the tail? And it has to do with the relationship between the mean and the median. So take a look for that. When we describe the center of a distribution of a quantitative variable, we're going to use either the mean or the median. The mean, or the average that we normally calculate, we find by just taking all of the data values, adding them up, and then dividing by the number of data values. The median is the middle value if we were to line the data up from smallest to largest, the one that would be in the middle would be the median. These are two different ways to describe the center of a distribution, and what we're going to see is that which one is the best choice for a particular variable is going to depend on the shape of the distribution. So that's another thing to look for as you're working through this week. A little bit more notation. Throughout the course, when we use the small n, that's going to stand for the sample size, or the number of values in the sample. When we're working with means, the sample mean is always going to be represented by x bar, x with a little line across the top of it, that's x bar. And the population mean is going to be represented by the Greek letter mu. So mu is the population mean, x bar is the sample mean. The median, we generally use the notation m for the median. Other summary measures we're going to see for quantitative variables include percentiles and quartiles, which give a sense of what the sort of relative position of a value is within the data set. The standard deviation, the range, and the interquartile range, which all describe how much variation or how spread out the data are. Those are going to be very important. And the 5-number summary, and graphically this is often represented with a box plot, which will give us a sense of sort of the overall distribution of the data. We'll also look at how we can describe relationships between variables. When we're working with two categorical variables, we'll often try to use a two-way table to start to examine the relationship between the variables. Here it's looking at whether or not there's a relationship between a person's gender and whether or not they're in a relationship, as reported on Facebook. When we're dealing with two categorical variables, we focus our inferences on looking at the difference in the proportions of one categorical variable calculated for the different levels of the other. So for instance, the proportion of females in a relationship minus the proportion of males in a relationship. When we have one categorical and one quantitative variable, we often visually look at the relationship between those variables using side-by-side box plots, which we can see an example of here, looking at interferon gamma level between people who are drinking coffee and tea in an experiment. And we focus on a difference in means for the quantitative variable calculated for different levels of the categorical variable. So here the mean interferon gamma level among tea drinkers minus the mean interferon gamma level for the coffee drinkers. When we're looking at a relationship between two quantitative variables, we represent that graphically using something called a scatter plot. And we will summarize the relationship using the correlation, which is a measure of how strong the linear association is between two variables, and the regression line, which is an equation that models the linear relationship between variables. It's important to make sure that we have a linear relationship, however, before we start using a regression line. So those are just some highlights and kind of things to look out for as you work through Module 2. I hope that you enjoy this module. If you find that you have questions, don't forget to post them to the Module 2 help discussion board. And I look forward to talking with you about the material. Have a great week.